Let's take a look at topic 5.6, inverse relations and functions. We're going to tackle example 1, represent an inverse of a relation. So let's recall what a function is. For every x value, each x value can only have one y value. So remember here that that x value, this is your input, which gets you, this is your independent variable. And your y value, that's your output. Remember, that's kind of like your answer. And your y value is the dependent variable. Because it depends on whatever your independent variable is. It can change. Now, what we're saying here, each x value can only have one y value. That means, if you think about it, if you have a function and you put in a number, some input value, you expect once you evaluate that function, you're only going to get one answer. So if you were to get two answers, so you put one value in, but you get two different answers out, that doesn't just really happen. It is not therefore it would not be a function. So here we go. Here's an example. We have a relation. Let me get rid of this. We have a relation here. It's not necessarily a function. There's a relationship where we have ordered pairs. We have an x value, we have a y value, that creates an ordered pair. If you look at it, each x value, first of all, the x values don't repeat. So therefore, each x value has its own y value. It's okay that the y values repeat, as long as I don't, say for instance, have -2 equals 1 and then -2 also has a y value of 5. Then it would not be a function. So this is a function. Now, if we're going to look at an inverse relation, what we're going to do is we're going to swap x and y. So that means now all of my y values become my x values. So I would have 1, 4, 3, 1. And now my x values become the y values. So we have -2, -1, 0, 1. And now notice how your x values repeat here. I have two x values of 1, and notice this x value of 1 has a corresponding y value of -2. This x value has a corresponding value of 1. That creates a problem. So therefore, right here, those make it not a function. And it is because I have an x value with more than one y value. Now, if we do have a inverse function, we use the notation. It looks like f raised to the -1st power, but we read that as the inverse of f. So let's take a look at this triad. We're going to identify the inverse, and is the inverse a function? So to do the inverse, all I need to do is swap the x and the y. So this one is going to be our inverse. So all my x values will be the y. What were the y values? 9, 7, 5, 3, 1, -1. And my y values, the x values. 1, 0, 1, 2, 3, 4. And now let's take a look. Well, notice here your x values do not repeat at all. So therefore, each x value has only one y value. So this is a function.